Okay, you're asked to evaluate G of 2.99 and G of 3.01, just given this bit of information right here. Okay, and here's a graph of what's happening. This graph, this blue graph, is actually the graph of G of X. Don't worry about how I got that. That's another topic. Okay, but this black line is the tangent line at 3 comma -5. And if you notice in the vicinity of 3, that you can't hardly distinguish between the tangent line and G of X. And that's what we mean by a linear approximation. We are going to find the equation of this tangent line, and it's going to be used as an approximation for values of G of X where X is very close to 3. You can't hardly tell the difference. Okay, so how can we find the equation of that tangent line? Well, first of all, you have to know that G prime is a formula for slopes of tangent lines. So even if you don't know what this blue graph looks like, you can find the slope of that line. Put 3 in for X, or evaluate G prime of 3, and the slope of that black line is 4. And now we know the slope of that line, and we know a point that it passes through, 3, -5. That's the point of tangency. So how can we write the equation of that black line? Well, I would use point slope. Y minus y sub 1 is -5. So y minus a -5 is y plus 5 equals the slope, 4, times x minus x sub 1, which is x sub 1 is 3, the x coordinate of the point of tangency. So we can rewrite this as y equals 4x minus 12 minus 5 is minus 17. That's actually the equation of this black line right here, 4x minus 17. And so we can write that. This is what we call linearization. L of x, the linearization of G of x, is 4x minus 17. So if we want to find the value of G of 2.99, well, we're going to use the linearization function to approximate G of 2.99. So it would be 4 times 2.99 minus 17. And L of 3.01 would be 4 times 3.01 minus 17. Now I'm going to get a snapshot from Desmos and paste it on board 2. So here we go, board 2. And remember, you don't know how I determined f of x. Actually, I should have used big G instead of f. Okay, it's the antiderivative of the square root of x squared plus 7. And I actually used a technique called trigonometric substitution. But here's L of x, and here's L of 2.99, -5.04. Look how close that is to the true function value, very close. And L of 3.01 is -4.96. If you round G of 3.01 to 2 decimal places, wow, you get the same value, okay? And back to board 1, I wanted to mention that this green dashed line, that's actually G prime of x. It is the graph of the square root of x squared plus 7. And you can see when I find G prime of 3, there's the point on the derivative that tells you that the slope of the tangent line is 4, which we figured out right over here. Okay, so when you see something like linear approximation or linearization for a function, you're actually finding the equation of a tangent line at the point of tangency of that tangent line to the graph of the given function. There you go. Hope that helped clear up your confusion. And if you have any questions, post a comment.